Good morning, fourth grade friends, and welcome to day 1 of lesson 27. This week we're going to be comparing decimals. So for today we're actually doing a couple different workbook pages. We're doing pages 557 through 559, and then we're also going to be doing 561 and 562 together, and then you'll be doing page 560 on your own. So we're going to jump right in with 557, and we're going to be working on comparing two decimals to the hundredths and explaining how we do that. That's our goal this week, okay? So, Kelly and Casey each buy equal-sized bottles of water. They each drink some of their water. Kelly now has 0 and 5/10 of his bottle left. Casey has 0 and 4/10 of her bottle left. Who has more water left? So first we're going to go in and underline our important information. So they start with equal-sized bottles of water. And then Kelly now has 0 and 5/10 of his water bottle left. Casey has 0 and 4/10 of her water bottle left. Who has more water left? Okay? So, Kelly, I'm going to call him Kelly, has 0.5 or 0 and 5/10 left. And Casey has 0 and 4/10 left. So what we can do is we can turn these into fractions. So remember, we're reading this 0 and 5/10. That means our 5 is our numerator, 10 is our denominator, because it's 0 and 5/10, okay? Because it's not a whole, it's 5/10, so 5 out of 10. Casey has 0 and 4/10, so using the same strategy, the 4 is going to be our numerator, denominator is 10, okay? And then it's easy. Which number is bigger, 5 or 4? 5 out of the 10 shaded or 4 out of the 10 shaded? Obviously, 5 is bigger, so who has more water left? That is Kelly. So we can say Kelly has more water left because, oops, sorry friends, I didn't realize I wasn't showing, because 5/10 is greater than 4/10. And another way to show this, boys and girls, if I just keep this going with Kelly and Casey, Kelly has, we have 10 pieces, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to shade in 1, 2, 3, 4, 5. And then Casey is 4/10. So same strategy. I'm combining this one. I accidentally made an extra one, so that's the whole bottom one. And then if we look at Casey, who also has 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, boys and girls, just realized it cut out, so we're going to jump back into where we left off. So Kelly has 5/10 and Casey would have 4. So 1, 2, 3, 4. And then we can use what we know about fractions and see that this is obviously bigger than this. Obviously, they're not the most even because it's Miss Dion drawing here, but you get the point there. So Kelly has the most, okay? So you could have done a model like this, or you could have changed it into fractions like this, okay? So that's step 1 of comparing decimals. So if you have any questions, please pause here. If not, we're just going to flip on over to page 558. So number 1, does Kelly or Casey have more water left? Explain how you know. Well, we already said it was Kelly, right? So Kelly has more left. .5 is greater than 0.4. And we can also just copy the same thing we wrote on the previous page. 5/10 is greater than 4/10. Okay? So that's just explaining how we know Kelly had the more water. Now looking ahead, you can compare decimals to decide who has more water left. So suppose you have two of the same size water bottle. One is 0 and 8/10 full, and the other is 0 and 9/10 full. Compare the decimals 0.8 and 0.9 to tell which bottle has more water. Write both decimals in the chart. So first one, we have 0 and the 1s for both. Obviously our handy dandy decimal point. The first one's going to be 8/10 and the second one is going to be 9/10. And then we just compare them from left to right, just as we would with whole numbers. So starting here, we both have 0, they're the same. Here they're different. So which one is larger, 8 or 9? 8 is smaller than 9, so 9 is greater than 8. So that means 0 and 9/10 is greater than 0 and 8/10. So that's a different strategy you could do there, okay? So then, which has more water, the bottle that's 0 and 8/10 full or the bottle that's 9/10 full? Obviously, the bottle that is 9/10 full, right? So the bottle that is 0 and 9/10 full of water has more. And we can say again, just using what we did over here, 0 and 9/10 is greater than 0 and 8/10 because 9 is bigger than 8, okay? So now, we're not going to write anything for number 3, I'm just going to talk you through it. So suppose the water bottles were different sizes. Could you compare the bottle that is 8/10 full and the bottle that is 9/10 full in the same way? That is no, because they're different sizes, okay? So I'm just going to write no. They need to be the same size to compare. We knew that with fractions, right? We can't compare fractions, different denominators, because they aren't the same size. So they need to be the same size, okay? So friends, if you have any questions on page 558, please do so now. If you do not, it is time for some vocabulary, okay? Really not vocabulary, actually, it's more like just examples. So we're going to compare some, okay? So, an example of comparing fractions is to tell whether one decimal is greater than less than or equal to another decimal. Okay, so that's in word form. And now we're just going to use some picture or model examples. So we're going to set up a table like we did, or that we filled out on the previous page. So we have ones, and then we have tenths. Sorry, I'm squishing a little, I apologize. So we could have 0 and 3/10, or, oops, we could have 0 and 8/10, okay? So that's another type of example. Another idea of comparing decimals could be 0 and 8/10 is larger than 0 and 7/10, or 0 and 8/10 is less than 0 and 9/10, okay? Can also transfer into fractions. So if we have 0 and 3/10, we could call that 3/10. And then if we had 0 and 4/10, we could call that 4/10. And then we could say that 3/10 is less than 4/10. So that means 0 and 3/10 is less than 0 and 4/10. Okay, see what I'm doing here? I'm just making some examples so we have a model to always refer back to. Another one we could do is if we had something divided up into fourths. I'll try to make them as even as I can this time. And I have 3/4 and I have 2/4. Obviously, hold on, I did the wrong thing. I apologize, friends. I can't fit 10 here. There's no way. I'm just going to pretend here. but we can say 0 and 2/10 is less than 0, and we'll call that 7/10, okay? It gets tricky with the marker to do tenths for sure. And then we could also have it this way. So we could say 7, we're gonna pretend that's 10, and we're gonna pretend this is 10, just for the sake of an example. And we could say 2, and then we could say 8. Obviously, 8/10 is greater than 2/10, right? So using these different models is going to be helpful for us. So if we look at number 2, compare the decimals 0 and 4/10 and 0 and 5/10. Write both the decimals in the place value chart, and then write to compare. I want you to show me. Okay, so show me what you're doing for number 2. And then you'll be ready to move on along to the next page. We have 2 more pages to go, friends, and then we will be good for today. So if you have any questions, please join, and do not forget to show me number 2. Now, page 561, same idea, just now we are working all the way into the hundreds. So instead of stopping in the tenths, we're adding a place value, as we can see here. Now it's tenths and hundreds. So Dora lives 35 hundredths of a mile from school. Katrina lives 53 hundredths of a mile from school. Who lives a greater distance from school? So really this question is asking who has the bigger number here, right? Who lives the greater distance from school? So Dora is 0 and 35 hundredths away. Katrina is 0 and 53 hundredths miles away. So now we can do the same idea we did with converting into fractions if you like that better. So 35 would be our numerator, our denominator would be 100 because we're in the hundredths place. And then same thing here, numerator is our number, denominator is 100. So then it gets just comparing numerators because the denominators are the same. 53 is greater than 35. So that means that 0 and 53 hundredths is greater than 0 and 35 hundredths, which means it's Katrina lives a greater distance from school. And then same idea, you could also just look at the 35 and the 53. Obviously the 53 is bigger, so that's the bigger number. However, that does not mean that all the time you need to make sure it's the same place value there, okay? So you can't have 3/10 and 53 hundredths and do that. It only works when you have the same place value, okay? So if you have any questions on page 561, please pause here and ask. If not, we're just going to read through this super quickly, a couple different ways you could have went about solving this. So we could have drawn a hundreds grid like this, right? So we have 100 boxes here, 35 are shaded. Here, 53 are shaded to show 35 hundredths and 53 hundredths. And then it's clear you can see that the 53 hundredths is shaded more, meaning 53 hundredths is larger, right? And then same thing with here. Obviously, if you just compare, the zeros are the same, decimals are the same, but the tenths are different. 3 is smaller than 5, so if that means 5 is greater than 3, that means this number obviously has to be larger, okay? So you're using a lot of your number sense here and putting it all together to help solve these problems, okay? So if you have any questions at all, I know this is a longer video, but I promise tomorrow will be shorter. You're going to be working on page 560 on your own and showing me on either our Google Meet or on Seesaw, okay? So I am here if you need me. Happy decimals!